Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your classwork and we have refraction of light, paper 1 for core and extended. Okay, I will start by question number 3. What causes the change in direction when light travels from air into glass? What happens when light travels from a medium to another medium of different optical density? What do you mean by optical density? This expression is different, totally different from the actual density we discussed in unit or topic 1. Okay? Here we are discussing refraction of light. Refraction of light. For example, if we have two different media like glass and air, we have boundary and we have the normal line which is perpendicular or at right angle to the boundary, and we have a light ray travels from air into glass, for example. So here from air into glass, the light is traveling in this direction, the light ray. So we have here the incident light ray. And we have two different media. We have here air and we have here glass. What is the difference between air and glass? Why we consider them as different media? Glass, we call it less dense. Air, is less dense. Glass here is denser. It has more optically denser. Optically denser. What does it mean optically denser? Means having a greater effect, having a greater refraction effect, having a greater refraction effect. So the light ray will not continue in a straight line. It will bend towards the normal. Why? Because it's traveling now from less dense to denser medium. So it's traveling from less dense to denser, so it will bend, it will refract. So this is the refracted ray. And the angle of refraction is the angle between the normal and the refracted ray. So this is R. The angle of incidence is the angle between the incident ray and the normal. So light ray will be refracted, changing its direction and its speed when it travels from medium to another medium. What causes that change in direction here is the speed of light. So as the light enters different media, its speed will be changed and its wavelength also will be changed. Frequency is constant. So only the frequency is constant. So what happens here when the light ray enters glass? Its speed will be changed. Okay. Question number 4. The diagram showing light traveling from glass to air. So here it's the other way, the second case. So we have here normal to the boundary. So this is the boundary. And you know that air is less dense. The glass here is denser, medium. Okay, as the light ray travels from denser to less dense, what happens here? As you can see in the diagram, it refracts away. So the refracted ray away from the normal. So the second case, it refracts away from the normal. So this is the angle of refraction. So here is asking you about the angle of refraction for this ray of light. The angle of refraction for this ray of light is not 20. No, it's the angle between the refracted ray and the normal. So this angle. So you have 90 minus 20 is equal to 70 degrees. Because you have this normal is 90 minus 20. The answer is 70. So the answer is D. Okay, let's move to question 5. Okay, question 5 is asking you here, it's somehow challenging. Is asking you which diagram showing what happens to the ray. So you have to check diagram is correct. Correct arrows, correct angles, correct rays, all the details in the diagram. So what happens to the ray here? The condition we have that light ray is traveling from glass into air. So from denser to less dense. Okay, from denser, so air is less dense and glass is denser. You know that when light ray travels from denser to less dense, it bends away from the normal. Okay, but here we are discussing new concept, which is critical angle. What do you mean by critical angle here? It's given 42. Critical angle, if you have a light ray, okay, this light ray strikes the boundary, at a certain angle, which is called the critical angle, okay. What happens to the ray? Number one, it passes from denser to less dense. So this case, it has some requirements that light ray travels from denser to less dense. Okay, what happens to this ray? If the angle of incidence is equal to the critical angle, the ray will be at the boundary, like this. Okay, if the angle of incidence is more than the critical, so if you have here another case, the angle of incidence is more than the critical, the ray will be totally internal reflected. In this case, you have to draw normal line again. Since we are discussing classwork, so we should explain in detail some different concepts. Okay, so the angle of incidence here should be equal to the angle of reflection according to the law of reflection. This case we call it total internal reflection. Why we call it total? Why it's called total? Because in the normal refraction, some rays here like this one, this is called weak reflected ray. So it's weak. So some rays are refracted in air and some weak light rays will be reflected. okay? But here, no refraction here at all, and all the rays are totally internal in the denser medium, reflected inside the denser medium, okay? So that's why we call it total. So we don't have partial refraction, partial reflection. No, we have total internal reflection. Back to our question. So now the critical angle is not equal to the angle of incidence, because we have the critical angle is 42 and the angle of incidence is 40. So it's not this case, and it's not total internal reflection. So what happens here? So we cannot choose D, B, and D it's incorrect at all. And this one could be correct, but the refracted ray is towards the normal. No, from denser to less dense, the ray should be away from the normal. Okay, so the correct answer is A.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.